Welcome to my study of brake temperature test. In this video, I will show how I built a temperature sensor to log brake temperature in real time. What makes this project special is that all code was written by AI based on my text prompts, showing how AI can help solve real problems. This project began after a road descent when my brake stopped working well. The brake lever felt soft and the stopping power was much less. An interesting moment worth investigation. I thought heat might be the main cause of brake problems, so I decided to gather data to find out how hot the brake will be. For this project, I choose an ESP32 board because it's small, is energy efficient, and has wireless feature to collect data during my ride. I have tried to use an handheld IR-based sensor, but they don't work well with shiny metal parts like the brake discs. So I choose a K-type thermocouple, which touches the brake pad directly and gives much accurate readings. Next, I need to solve how to gather and view the temperature. I could have data stored in the ESP32 itself, but this would make it hard to sync with my ride videos. Instead, I decided to send the temperature readings as if they were bike data, just like speed or heart rate, which were already integrated into my data pipeline. Here's the full setup: an ESP32 connected to a thermocouple interface. For coding, my first try was to broadcast the temperature as heart rate data. It worked. The system got readings and sent them out, but the value is not correct. Also, only Runkeeper could see the data, and it only saved data every 30 seconds, too slow to catch the temperature differences. Using power meter data turned out to be the best choice, as it supports higher values. The Wahoo app records power data every second, providing much better insights into brake heating. By testing the sensor with a lighter, I was able to confirm readings in the hundreds of degrees on the app. Here you can see me attaching the thermocouple to the side of the brake pad. This spot gives good reading while not getting in the way of how the brake works. Here's the soldering result. To check the accuracy of the thermocouple, I tested it with iced water. As you can see in this screenshot, the sensor reads 2 degrees, which is close to the expected temperature for iced water. I ran tests on different road gradients to see how temperature changes. I used aero precision and only used the front brake for all tests. On the top left, it's a minus 10% gradient. It reached 176 Celsius when I only do heavy brakes before turns. The brake worked fine. The top right has the same gradient, but with steady, soft braking. Temperature went up to 200 Celsius. The brake is still good. On the bottom left, it's a steeper minus 20% gradient. Temperature went up to 208 Celsius, and I felt brake fade. The brake slowly lost power. By switching to the back brake to let the front one cool down, I got normal braking power. On the bottom right is a minus 15% gradient. At 193 Celsius, the brake is making great noise and gradually locked up on its own. This seems to happen when brake fluid gets too hot and makes more pressure in the hydraulic system, strong enough to stop the bike even going downhill and pedaling. Here are some limits of my setup. First, since the thermocouple is on the side of a brake pad, not where it touches the disc, there's a delay in readings. The heat is generated at the rubbing area, so my readings are likely lower than the true peak temperature. Second, when the temperature is higher than the solder melting point, the tip can lose over time, making later test readings less exact.